Welcome to another tutorial I will be posting on Wickerson Studios on Patreon. I am looking into scripts through Grasshopper for Rhino 3D program, making CAD design extremely generative and computational, and certainly parametric. I will leave this little turntable tool for now and show you the powers of going into very simple tools within the maths dealing with polynomials and going from cube all the way through the natural logarithm. I think I'll actually stay with 1 over x and go down to natural logarithm. And we'll write this script. The script itself is fairly simple, and we may actually try some extrusion on it when we're done. So what I'm going to do is delete that script and show you how it's made. What you want to do is make sure that everything's available, actually, when we make it. And how I operate and I want to teach is I like going in the vectors and making points. And I basically think, okay, here are 2 points. Now what can I do with them? What are the attributes I'd bring to those? And in order to generate points, it's best to go into sets and think of a series or a range to begin. So you have a list. And with that range, you're always want to go into maths and pull yourself up a domain. And you'll want a series of steps that will play off of the height, probably, if I do that in z-axis. And I also like to set my domains so that 0, 1, I never go below 0. I never get a 0 number. So I've got a nice little sense of data coming out. Here it is. You can look at it as a panel at any times, or you can look at it as a param viewer to find out what exactly is there. 22 items, and there they are. They're numbers. And numbers are a great thing to begin by building points. So what I'm going to do is actually use another one of the maths and do an addition. So I have a little bit of control of moving things, and I'm going to use a 2.00 slider, which will range as a rational number, and I will put that into probably the x-coordinate. So I've got this kind of staggered off-center points. And there they are as a range. There's one here, and they're both exactly the same currently. What you can do is go in and influence this range through graph mappers, but what I like to do is jump into the maths a little more and grab things like 1 over x. Let's grab power of 10. They should be staying on my thing, but they're not. Power of 2, there we go. And power of e. These may be familiar to people thinking back to their math classes, logarithms and natural logarithms. And you can have an effect on those numbers when you actually, I think you'll need a number in this log n if you need a number to it. So basically I'm going to run through and we'll set that to an 8 count. Sure, and let's take our range and throw it into the base number on log n, log 8, and let's put that up into the z factor here. And now we've done something to those points. We've lifted them up in a very interesting way using that function of log. At the same breath, I'll use ln n, put my range into that, natural logarithm, put it into here, and I have another curve. So I have this curve and this curve. Now they both are doing some interesting things. I do want to take them both. I'll just keep sliding this on. You can see we can always analyze what we have coming out, a point system now, and a certain amount of data. 22 as well. So you can always keep checking what you have. But what I'm going to do is go into my transformations and grab a polar array, and I'll grab another polar array, and I will simply put my geometry into that one and array it and keep my count fairly low on both consistently to 3. So count 3, bring this geometry into here, and I made a little mistake there, so control not to release and then plug that in the count. And now I have 3 and 3 patterns revolving, and there they are, inside and out. Now I think of those two things as pretty interesting objects, and what I'd like to do is, first of all, I'd like to interpolate them, and that's something I do all the time. And it may not be the data I want initially, but let's pull in those points and make them into a line. So you can see we go from number to attributes to a point to line, and there's a problem with this one. And this one seems to be taking okay. This one's got a little issue. What could it be? Insufficient interpolation points. That may be just because of the setup of the curve. But what I'm going to do with this is I'm not actually going to interpolate in that direction. I'm actually going to go into params, into sets, and go into my tree data and go into my flip matrix, and I'm going to flip this data and bring it in. And it shouldn't have any trouble reading now. And the same thing I'm going to do with another control paste data, and I'm going to interpolate this way. So I got lines going this way and lines going this way. Now these two can now, very interestingly, once you've interpolated, you can actually take that data, and we'll just keep moving this along so you can see the curves are now curves, and that's how much data we have. I can actually use a Boolean. If I typed in Boolean, not Boolean, Boolean toggle, to make these true when it comes to being periodic, and that will close them up. Now I have 3 closed loops and 3 closed loops. They may not be in the correct order of what I want, and this is where I could get into a weave pattern, think logically what I want to do, but I'm a list item type person. So I will grab a list item and make 2 more items in that list, and I will grab those, and I will do that again to grab that item again here, and I will say I want to know what I'm grabbing as curves. This one. The one thing I have to do is take my, if you look at this, it's a list of lists. I just want a list. So I'm going to flatten that data and take that tree down a branch and put all the items into one kind of basket. Not flatten it completely, well, flatten it down to that. So now I have items, I have this loop, and if we watch as we go around, it's kind of hard to see with this pale color. This loop is next to it, which is okay. It's not staggered. There's something strange here that I've flipped the data, but the data in the rotation has remained. I actually think there's one other thing I want to do to it. I flattened both data. We'll see how it interpolates. I actually wouldn't mind having this data flip directly over, and I think that's exactly what I'm going to do. I'm going to go back into the angle on this. I forgot to put in a rotation because I don't want to deal with these lined up to one another. So I'm going to go into a transform, rotate 3D, and I'll show you exactly what I'm going to do. Take that geometry and rotate through pi, one full flip. And if I type in the digit 1, I can take that, and basically I am flipping that, and I will internalize this data so it's always 1 pi. And I will take that data, and you'll see it's been flipped from here to here. And that way they're not lining up. But that's going to screw up my order of my geometry as I bring it in. So now I have to think, how can I actually loft these objects, because I've been playing with them in that strange way. How can I loft these objects in order? I could use a merge tool in order, but I'm not going to. I'm actually going to put them in order. So if I start with this curve, this big one, I'm going to want one of these small ones on each side afterwards. And I'll shrink this down so you can see it. So I'm going to want this one next or this one next. So I'm going to put that one in. And with shift, I'm going to take a look at, well, without shift yet, I don't want that one. I could use this one. I'm going to hold down shift and put that one in next. Then I'm going to come back and I'm going to grab this one. Sorry, this item. And I didn't mean to. I'm going to have to restart that. I'm going to put that one in. Put in my first starter piece. I'm getting a little funky here. Put this one in. Then I'm going to choose that one second. Then I'm going to take this one. And that's not the one I want. I'm going to take this one, which is next in line. Hold shift and put that one in. You can see that it's getting a little tricky. Now I've got to come and find this mystery object over here. It's like weaving things together. Let's see what this one is. That's not the one I want, so this is the one I want. And that leaves this one. And as long as I loft it in that order, and I take a look at that object, I've got some crazy little geometry going on here, and a crazy little form that's pretty elongated. Kind of an interesting little thing. And there it is as a blue object. I could go in to close it under loft items. That's a pretty necessary thing to do. Close the loft, and I will align things so they run very nicely. You see how it smoothed itself out. Now I have a geometry. I'm going to shrink. I'm going to bring it back here. I'm going to take my picture over here. I'm going to go to Standard, View All, zoom in, and say, okay, there's something. And in zooming out here, I'm going to lose track of seeing everything but that final object. I'll take that all off preview. So I'm only looking at that final object. And there it is. It's a pretty interesting device. whatever you want to end up thinking of using it as product design. But what you can do now is you can actually swap things out. You actually could take that geometry, and as long as you plug in your ranges into all these elements, you can try different patterns on these polynomials. So instead of this one and this one, I could take this one and override it. And look at that strange shape I just ended up with. Beautiful lines, beautiful continuity. You can take it into EMAP, you can bake it and see what you have. Let's try this one. And I just put it in the Y, which I accidentally didn't mean to do. So I'll leave that, come back over here and take out the Y. And let's plug that one in the Z. You get a very tiny little object revolving around. I'll try turntable again. There we go. And these are solid up. These do not need to be extruded. These are actually watertight meshes with no non-manifold edges and no naked edges. So you can actually take these right into bake. There's another little short one. What happens when I put the short one with this one? It drops on the other side. What if I switch this one with that one? I get a totally other form. This kind of strange propeller that I can analyze and think about. What a wonderful way to gain some beautiful geometries that are tied to maths. And there's another one exploding up in that direction, similar to the first one I started with. Little cusp. Nice little objects to just bake and play with. There's one. I don't mind it. Awkward little shape. Can't say I would make it in Rhino. I might, but I wouldn't have as much luck. And there's the one I'm going to end with. I will take that and put it into bake. And it won't do anything while I'm in a command in Rhino. So let's put it into a bake. And I've got all these decisions of where to bake things because I have so many layers on. I'm going to bake it. And then I'm going to take it over into my rendered and leave this screen over here. And there's my little object. And if I didn't think it was in perfect shape, I'd try an EMAP and pull it in environment map analysis. And I could choose many different ways to see it. I think I'll just choose this one, turntable. And there you go. You get a nice perfect edges, smooth forms, kind of a fine seductive object at 12 minutes. The mistake I was making earlier, and I guess I will get into it, is I was carrying my script through a little farther and putting it into a really nice tool that's this script, and it's just waiting for an untrimmed surface. And you can see what can happen when I do this. Let's leave this and select this object to leave and put back on that object. If I took that untrimmed surface and I threw it through this surface that's waiting for an untrimmed surface, you'll see what happens. It's slowing down and it's trying to extrude the surface normals in all directions. And it has a little bit of a slowdown, but I've got a little bit of perhaps enable. I might have taken it off. That's all I did. I sometimes have to, I just didn't want to run that script. So I'm just waiting for this to think what it wants to do. It has to read all the maths there, and it's breaking that surface into a, constructing a 2D on it, and it's doing a BREP analysis, and it's doing some pretty amazing things right now as we wait at 13 minutes, and let's see what we end up with. And not too much happened, but it did balloon out and do something very strange, which I have parametric control over, but a very slow script. So there's the object we actually ended up making through this strange extrusion tool. And quite beautiful sculpture if you're into this, and I have total control over it. So that's a little thing I'll go into on the next one. But if you're looking to make some very elegant, beautiful forms, I would say follow this on Patreon. Have a look at what we're doing. I would never have made that in Rhino. And I will take that into a zebra. Actually, what you can do is you can just go into analysis, surface, and go into, you can do draft analysis, curvature analysis, just ZBrush. I'm going to do ZBrush, and you see I end up with this really nice form to take in the turntable. What a wonderful thing to end up with. Now, how did I make that? I used polynomials and maths and made, I think, a pretty outstanding object. I hope you enjoy it. Thanks for watching.